Hey everyone, in this video we are going to be graphing cube root functions. Alright, sounds pretty awesome. We're going to get ourselves a cube root function here. So y equals, let's say, the cube root of x. Let's just say minus 2. Okay. First we're going to make a table. That's going to be our method. Alright. Now, I am going to pick 0. Well, if I plugged in 0, the cube root of 0 is 0. 0 minus 2 is negative 2. So I have the point 0, negative 2. Alright, now the next perfect cube is 1. The cube root of 1 is 1. 1 minus 2 is negative 1. So 1 down to negative 1. Put a dot. Okay, then I'm going to put in negative 1. So I'll show you in a moment why. Alright, if I take negative 1 and I cube it, cube root, the cube root of negative 1 is negative 1. Why? Because negative 1 times negative 1 times negative 1 makes negative 1. Negative 1 minus 2 is negative 3. So I go left to negative 1, down to negative 3. You notice I have 3 points in a row. This is always important, and it always happens in every cube root function. What's going to happen is it's going to curve to an elongated S, but there's always these 3 right in a row. Okay? Now, my next perfect cube in the positive direction is 8. Because 2 cubed equals 8. So the cube root of 8 is 2. 2 minus 2 gives me 0. So I go over 8, 2, 3, 4, 5, 6, 7. Oh, looks like I need one more hash mark. So let me put that on there. And this would be 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep. Alright. Let me get my right color again. 8, 0 right there. So see how it curves over this way. Big difference between those 2 points for the next whole number coordinates. Now, if I want to have whole number coordinates going to the left, I need to plug in negative 8. Why? Because 2 cubed is negative 8. Or negative 2 cubed, excuse me, is negative 8. So the cube root of negative 8 is negative 2. Negative 2 minus 2 is negative 4. Alright, so I go over to negative 8 down to negative 4. Put my dot. Okay, it kind of looks like a mess, but see what it is. It's an elongated S-type shape. See, it curves, it goes up here, and it curves back over, crosses the axis there. See, almost reminds you like something that belongs on the side of someone's tennis shoe. Alright, now, we need to talk about domain and range of these. The domain for cube root functions is really nice. I can pick any number I want, plug it in, I can get an answer. Whether it's a positive, a negative, or 0. I might get decimal values, but I'll still get an answer. So the domain is all real numbers. The range, however, is a little different. Or is it? Actually, it isn't. Because I'm always going to get an answer for y, and it's going to keep going up here slowly, but it will. It's going to keep going down here. So the range actually is also all real numbers. So a lot nicer than the square roots. Okay, so all real numbers. So domain and range for all cube root functions are all real numbers. Alrighty, have fun graphing these.